probability, rolling a die is one of the most popular word problems you're going to see. And they're actually pretty simple if you think about it. When it comes to rolling a die, remember, a die has six possible options. You got landing a 1, landing a 2, how do you write 2? Landing a 3, landing a 4, landing a 5, and finally landing a 6. Those are the only possible options you can get. So in theory, uh, what is the probability that you show a 1? Well, because there's only one option and there's six possible options to get, like this here says, you have 1 out of 6 probability of rolling a 1. Now, let's say a student rolls the dice 60 times to see how many times he would get a 1. How many rolls should the student expect? That's a big word. Expect to get a 1. Now, remember what we said in class? We're going to discuss what's a theoretical probability and what's experimental. Theoretical is what should happen. So the student expects to get, well, we're going to roll it 60 times. You expect to get, out of those 60, you're supposed to get 10. Because 10 out of 60 is the same thing as saying 1/6 if you reduce it. So basically, that's what should happen. Now imagine if you actually did it. If you roll the dice, you might not, there's a high chance you might not get 10 rolls that are 1. So one is what should happen, and the other one is what actually happens. Theoretical, experimental. Now going over their other examples, look at this spinner. If you spin this thing 210 times, what's the probability you get an elephant? Well, how many elephants are there? I see 1, 2, 3, and 4. So there's 4 elephants. And how many options are there in total? I see, well, it's 5, 6, 7. So I see 7, right? So there's 4 elephants out of 7 options. So in theory, if that's what you get for one roll, multiply by 210. And let's see what you should expect. You see big. That's a big word. So let's multiply them. Let me get a calculator. 210 times 4 times 4, that's going to be 840. And what's 1 times 7? That's a 7. Divide by 7. So in theory, 120 of those spins should be an elephant. Emphasis in the should. Experimental, that might be a different story. And finally, look at this. Again, look at the dice. You can get 1 through 6, right? I just wrote them in numbers. What's the probability that you roll a 2 or less? Well, look, a 2 or less means I can get the 2 or I can get the 1. That's 2 out of how many options? 2 out of 6. So if I reduce that, that's a 1/3 opportunity. What is the probability that you roll a 3 or greater? A 3 or greater. You see, that's 4. Once again, out of how many? 6. When you reduce that, you get a 2 out of 3. And the last one, what's the probability that you roll a 7? Well, I told you, the biggest number you can get is a 6. So we call this impossible. That's a 0 out of 6, which is a 0. A 0% chance of that happening. And what's the probability of rolling a 1 through 6? Well, is that everything? We call that a 6 out of 6, which is a 1. In other words, 100%. It's gonna happen. And what's the probability the sun will rise tomorrow? Again, that's another example of something that's for sure going to happen. I mean, yeah, the end of the world could be tomorrow, but it's very unlikely based on science and all that stuff. Now, another example of something that's impossible is what's the probability the Raiders will win another Super Bowl? Very unlikely. Very, very unlikely, just based on how the team is managed. Poor fans out there like Mr. Mendoza, always getting disappointed. But, yeah, it's almost impossible. Pretty close to impossible. If I could say 0%, I would. But again, I'd be doing a disservice to you guys. So very unlikely, Raiders. Fun fact, I'll keep saying this till they do. Fun fact, the last time the Raiders won a playoff game, you guys weren't even born yet. So there's a little fun fact for you guys. Make sure to tell it to Mr. Mendoza. And hopefully you guys understood this lesson. I'll see you guys next time.